Okay, so we're going to apply the exponential functions. Remember the general format of an exponential, right? When is it exponential growth? Do we remember? What does the value of b have to be? It's what? Greater than 1. And b is less than 1 is decay. I'm sorry, between 0 and 1 is decay. We're not worried about negatives right now. It kind of screws with things. Okay. Now, if we're going to use this in a science application, you're probably going to see a little bit of a different formula. So we have okay, so there's a different format, but you see that N0 matches with A, 1 plus R is B, and then T is X. One. So N equals N subscript 0 times 1 plus R, 1 plus R to the T. N is the final, so if we're talking population, this would be the final amount. N0 is initial amount. If you see anything pretty much in math with a subscript 0, it means that's where we're starting. Velocity V0, starting velocity. A sub 0, acceleration. R is the rate of growth or decay. Per time period. And T is number of time periods. Okay. So when we apply exponential functions, we have to consider a few variables, things that can change, right? But it's really not that difficult. So let's well, the example in your book is a bee population example. We're going to consider that the starting population is 500. And a growth of 14% a week. What is the population in 22 weeks? If you did that, that would be after 1 year or 1 week. Then what would you have to do? You have to do it 22 more times. So he had a good suggestion. If you take 14% of 500, that'll give you a population, right? That's only 1 week. Do you want to do that 22 times? No, you don't. That's why this is the nice formula of having a head pocket. Because it allows you to do it in one calculation. So where does the 500 go? And what? Yeah, N0. Where does the 14% R, and I have to change it to a decimal. So keep that in mind, and then 22 weeks goes in for T. So final amount equals that right there. How much? Point what? So what would you say, how many B's would you say there's approximately? So that would be your kind of your problem answer. Okay. Easy enough, I think you can handle that. Let's plug it in. Understand the equation, plug it in. So that's kind of a population example. There are other formulas we can use for that too. We might touch on them later in the next couple of weeks, but this is what we use for now. All right. Okay, one more from finance. Okay, compound interest. Do any of you have savings accounts? Okay, several of you. Do you know how much interest you're bearing on that account right now?
Not very much.
Good. The right answer. Yeah, I think ours is like 0.15% or something stupid. Yeah. Yep. Yep. Okay, that's because the Fed has kept their base interest rate at 0, so banks peg theirs to that. But if you want to calculate how much possible money that's going to generate for you in the future, here's a formula. P is principal, so that's how much money's in the account at the beginning. R, of course, is going to be the rate. N is the number of times interest is paid per year. So pay attention to the N, because sometimes it's paid, they say paid monthly. Well, what would N be in that case? 12, right, because it's 12 times per year, or weekly. Okay. There's also something called continuously compounded interest, which we'll talk about in the next week, but pay attention there because they can throw different variations of the same thing at you. T is
number of years. Okay, A, of course, would be your final amount. All right, so lots of things happen in there. Do you guys know what certificates of deposit are? Anybody? A certificate of deposit, CD. Basically take like $5,000 and you buy a certificate of deposit from the bank for a certain number of years. You can't take the money out, you can't add to it. In 5 years it matures and you get more of your money plus interest. If the bank uses your money to give people loans. And so this is a good example of a formula we could use for a certificate of deposit. Okay. So if we have a CD with an annual interest rate, 5%, with an initial investment of $2,000, with a 7-year time period, and we're going to say this is compounded daily. The interest is compounded daily. The more frequently the interest is calculated, the better. Especially if you continue to add money to a bank account. But this is just going to be a static amount for 7 years, principal, with the interest on top. So what does the formula look like? How much money do we have at the end of 7 years? P is 2,000. Let's do that. 1 plus R. Remember, change the R to a decimal. What's N? Yep. Think you can handle that calculation? What'd you get? 138.067. So the final amount will be the funny thing about that 0.067, the bank will probably round it down to 6 cents because you haven't earned that another cent. Okay. They say, nah, you don't get it. We're not round it up. I'm pretty sure. Hey, any questions? None? Alrighty then. Do I need to write the work down again? Do you have it? Alrighty. It's due Tuesday. You do have about 20 minutes, so take advantage of